So today we get to start a series on calculus, which is really exciting. Um, it sounds like a really scary and tough subject, but I think you'll find it's actually quite easy. Um, the only thing I will say with calculus is there are some notations, a lot of new notations that's going to be thrown at you. And there's a lot of really big idea concepts that you probably really need to grasp while taking this class. So I'm going to go over a few of them. My goal is to make this a pretty long playlist, and I'll just go section through section. I'll look through my old calculus notes that I have over here and make sure that I'm touching on all the concepts that were important to me. And our first section will be talking about tangent lines and secant lines. Now, what is a secant line? A secant line will look something like this. I'm going to go ahead and first draw a graph of a function. And we'll just do f of x is equal to x squared, a parabola. A secant line would be something like this. So we take from one point to this point. Okay? Let's say this is when x is -1, and this is when x is equal to, 3. This line is a secant line, okay? The important thing we need to know here is the slope of our secant line can also be called the average rate of change, which I just denounced as ARC, which, if you remember, it's f of b minus f of a divided by b minus a. Or it's really just the slope of this line. It's some linear line. Hopefully you remember that from, I'm assuming, maybe an algebra class or pre-calc. Regardless, we'll go over a example. Let's say we have this function y equals x squared. Okay? I want you to find the slope of the secant line at the following points. So we'll start with 1, 1 and 2, 4. Okay? So to find this, we just need to find our slope, which is this is our x1, this is our y1, this is our x2, this is our y2. Okay? And when we're given 2 points, we can just say, well, m is equal to y2 minus y1 all over x2 minus x1. Okay? So that's 4 minus 1 divided by 2 minus 1, which, if you plug that in, you will get your 3 over 1, which 3 over 1 is just 3. So the slope of our secant line is 3. It goes up 3 and over 1. So that's cool. That's what that is. But with calculus, it allows us to do something a lot cooler. A tangent line, let's first define what a tangent line even is. A tangent line it touches a curve at one point. So I'll first, again, graph an example where you can kind of see what it is I'm talking about. We'll, again, just graph our parabola. And the tangent line, let's say it touches right here. We have our tangent line there. So the tangent line touches at just one point on the graph. This is fundamental to calculus, and it's fundamental to understand the difference between a secant line and a tangent line. In fact, my professor even made a note that that's going to be the first question on her final, because if you don't know the difference between a secant line and a tangent line, you really didn't understand what was going on in the class. Now, the other thing we really need to understand is this secant line gives us our average rate of change. Our tangent line doesn't give us an average rate of change. Instead, it gives us a rate of change at some value x. And this is fundamental. This is a huge key to calculus. So the tangent line is I don't want to use the word instantaneous rate of change because it's technically not. It's I don't know why I put that line there. It's a rate of change at one moment. At one moment, there's some rate of change. That's going to be pretty big, and let's demonstrate. Sorry about that. I have my phone propped up. Let me give you an example really quick. Let's say I want you to find the rate of change from a point x squared. Let's say just like we would with an average rate of change, okay? Well, again, we know our slope is going to be equal to, and then let me also give you, we need another points, duh. The point's 1, 1. Okay, so the same points there. Well, we know our slope is equal to our x2 minus 1 divided by x minus 1. Okay, so here's what we're going to do. We're going to make an x and an m chart over here to kind of demonstrate what's going on. So let's plug in some values for x, and I want our x values, let's put it right here, to approach 1. When you see an arrow like this in calculus, you might have seen this in pre-calculus as x approaches 1. So let's start off with 2, 1.5, 1.1, 1.01, 1.001, okay? And now what we're going to do is plug these values into here and see what we get. And I encourage you to plug this in your calculator. I'm a little low on time, so I have the corresponding m values if we were to plug them into this guy. So I'm going to put them down. 3, 2.5, 2.1, 2.01, 2.001. Well, that's interesting. It appears that as x gets closer to 1, the slope is equal to 2, right? We're getting closer and closer to the value of 2. That's fundamental. One last thing I'm going to finish off with here. There's a little more I wanted to cover with this topic before moving on, but I suppose this is sufficient, is to find the slope or to find the equation of your tangent line of this guy, okay? So we found that as our x position, our x value is getting closer to 2, that's what our slope is. So our slope is essentially 1, okay? Well, here's generally what we want to use if you want to find an equation. Y minus y1 is equal to m times x minus x1. Okay, well, we were given points up there, right? So all we have to do is plug that in. Y minus 1 is equal to our slope of 2. X minus 1 is equal to 2x minus 2. Y is equal to 2x minus 1. And now we have the slope of our tangent line. Y equals 2x minus 1. This is the slope of our tangent line that touches at x equals 2. Again, this is fundamental to calculus. I'm running really low on time. I only have a few seconds left. I hope this kind of makes sense. I plan on continuing this, but please give me feedback in the comment section.